Okay, there's nothing to do here. So you just basically say, okay, you can actually return false. Okay, I will tell you why. You can return false. The subroutine returns true when you find the cheese. Okay, so if you have been to a certain location already, that means that you have not found the cheese yet, and this is a location that you have already confirmed that the cheese is not in. Otherwise, what do? Now, this part here is going to be a little bit abstract. We don't have the actual mechanism in this class to implement it, but basically what you do is to say for each reachable neighbor, NEIGHBOR, cell C, do the following. Now this is a construct we have not seen in this class, so just kind of bear with me. Okay, so for each reachable neighbor cell C, do the following. The first thing you want to do, I forgot one thing here, is to mark location. I forgot a few things. Okay, if cheese is here, okay, then there's only one easy thing for me to do, return true, right? I found it. Return true, in this case. If this location, which is passed to me by value, does not have the cheese, then my job is to look around me. I will say, oh, I can reach that cell. Let me go to that cell and see if I can find the cheese over there. If that fails, I have to look into here. If that fails, I have to look into here. If that fails, I have to go look into there. So after this, then you have to say, while, let me see, what is the best way to do it? I'm just trying to find out how to write this in a way that we can understand in this class. Okay, we'll just do it this way. Okay. Found gets false. In other words, by default, we just say that, oh, we haven't found anything yet. And then you can say for each neighboring cell C, do the following. What am I going to do to each neighboring cell? I invoke search on that cell. Okay, so in here we say found gets found, or because if I find the cell, if I find the cheese, then it's found. So I would say found gets found, or invoke search, but this time I use cell C to specify my parameter location. And for, and if, and define sub. Okay. In other words, it is a recursive way of looking at things. Every time you are at a junction where the cheese is not here, but I have this cell is my neighboring cell, this is my neighboring cell. Let's say there's a wall here, I cannot access this side. Then I have to say, okay, I know this cell does not have the cheese, so what am I going to do? Well, the first thing I will do is to step into this cell here and see if in this direction I can find the cell. If in this direction I cannot find the cheese, I will head out to the alternative and say, okay, if I head out this way, can I find the cheese? Does it make sense? Okay, from the perspective of I'm standing right here and this cell does not have the cheese. So after this step, and I step over here because on this side, I'm over. It tells me to go to this cell here. From this perspective, what am I going to do? The same thing, isn't it? Right? Because at this point, I would say, oh, this cell does not have the cheese either, but I can reach this neighbor and I can reach this neighbor. Okay. So then the next thing I want to do is to say, okay, let's go ahead and let's say we go back here. But when I go back here, this cell is already explored, so I return false right away, getting back to here. But when I get back to here, I already know, oh, I have already explored this cell. I don't have to consider that again. So the next direction I have to consider will be in this direction. Okay? So you can see how this recursive algorithm will basically go as deep as possible without hitting a dead end. But when you do hit a dead end, which means there are no neighboring cells anymore, then this loop becomes a null loop, and then you will return false for this invocation back to the previous point where you can still explore more alternatives. And this is one application where recursion actually makes sense. I mean, it does make sense to use a recursive algorithm to try to solve the problem. You can turn this into an algorithm that does not have recursion, but it gets a bit more complicated when it is in that form. Okay, so I'm glad that you asked the question, because it is a very valid question. Whether we should be expressing an algorithm recursively or iteratively using a loop. Most of you, who will go to CISP 430 and also 440 will meet Mr. Fox, Professor Dave Fox, and he will tell you one thing, and you will probably remember from this class. He will tell you recursion is your best friend. So in those classes, you will realize how important recursion is. I'll see you guys on Tuesday. Have a nice weekend, and don't forget the homework assignment, okay? That's important.